Hello everyone. The title of this video is Using a Graph to Determine Where a Function is Increasing, Decreasing, or Constant. So every example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org, and I'm in their Algebra and Trigonometry text, section 3.3, Rates of Change and Behavior of Graphs. And I'm under the heading Using a Graph to Determine Where a Function is Increasing, Decreasing, or Constant. And each example I'm going to do is either going to be an example from the reading or a try it problem from the reading or one of the exercises at the end of the section that is related to this particular objective, this particular heading. Okay. So we're asked in all the exercises I'm going to be working on, or at least in these first couple, we're going to be asked to estimate the intervals on which the function is increasing or decreasing. So first I want to talk about, how do you look at a function, the graph of a function, and, state where a function is increasing, decreasing, or constant. All right, so I'll make this little note here. For every single one of these concepts, where a function is increasing, decreasing, or constant, we're talking about the outputs. Is the output increasing, decreasing, or constant as the input increases? So basically, we're going to always look from left to right. We're always looking from left to right on the graphs. And see what happens to the outputs of the functions as the inputs increase. Alright, so for example, here's a little chunk, a little tiny drawing of the XY coordinate plane. The inputs are, represented by the horizontal axis, the outputs represented by the vertical axis. Now suppose I had this interval here on the x-axis from, say, x equals a to x equals b. If, as I look from left to right, as I go from x equals a to b, the graph of our function is going up in some way, the y coordinates are increasing as the input increases, then they would just simply say, instead of saying all that, instead of saying, the values of the function are increasing as the inputs increase, they'll just say the function is increasing. They'll just say the function is increasing. And then typically they'll state, or they'll ask you to state, where is the function increasing? Over which interval on the x-axis is the function increasing? So we would say that the function is increasing on the interval, and then from a to b, and I'm writing this in interval notation here. Now notice that this is an open interval. Right, both ends have a parentheses, right? And this is the way it should be, right? Is when you state an interval over which a function is increasing, decreasing, or constant. Should be an open interval. Don't include the ends because it's only going up, in between a and b. It's not going up at a particular point, right? At a particular end. So as I increase the inputs, the graph is going up, meaning the outputs are increasing, and the outputs are the value of the function over this interval. Okay, so that's one. Now, if I do the same kind of picture, again, here's the x-axis, y-axis, and then here's, again, an interval on the x-axis from, say, A to B. If I increase the inputs, go from A to B, go left to right, and the function's doing something like this, right, where it's going down, then you would say that the value of the function is decreasing over the interval from A to B, right, as the input increases from A to B. But instead of saying all that, we just simply say the function is decreasing on the interval or over the interval AB, right, from A to B. And again, open interval, parentheses on the ends. All right, so increasing, you're looking from left to right, it's going up, right? The value of the function's increasing, the outputs are increasing. And decreasing on some interval, you look from left to right on the interval, the graph is going down the whole time. The outputs are decreasing. And the one we're not really asked about, because it's only going to happen for constant functions really, or piecewise defined functions where a particular piece is constant, is where is a function constant over some interval. So again, here's a little small version of the xy plane, and just suppose I'm looking on the x-axis here on the interval from A to B. A function would be constant if it is, just over some interval. If it's just totally horizontal, doesn't change value. The y value doesn't change at all. The y value remains constant. So for a piece of graph like this, they would say that the function is constant. On the interval from x equals a to b, right? But again, just an open interval, right? You're not talking about being constant at a particular end, right? All right, so just straight up horizontal piece. All right, now this should be easy to determine, right, when you're actually looking at a graph. Over what intervals on the x-axis is the function increasing, decreasing, or constant, going up, going down, or staying flat? All right. So let's take a look at example 1. And I'm going to the exercises from the section, starting with exercise 18. Scrolling all the way down here. There's lots of stuff in this section. To the exercises. All right. And exercise 18, and like I said, they're asking us to use the graph of the functions given to estimate the intervals on which the function is increasing or decreasing. All right, so here's our picture for function given to us in number 18. And we see the arrows on the ends here, meaning it's going up forever to the left that way and up forever to the right that way. And I got this point at the bottom where it does a turn. Right, this looks like one of them absolute value functions, right, like a V shape. And this looks like the point 1, -3 down here. In fact, I'm going to draw a rough sketch of this curve on paper, and we'll talk about where the function is increasing or decreasing. Alright, so here we go. I got just a very, very rough sketch of it. I only put up the number that's really important on the x-axis here. And as I mentioned earlier, when you're asked about where is a function increasing or decreasing or constant, you're always looking from left to right. So look at this graph from left to right, and as you go from left to right, you see on this piece of the graph, the y coordinates are decreasing. The outputs are decreasing. The value of the function is decreasing. So from here all the way up to 1. All right, now notice this is to the left forever. So from the left forever all the way up to 1, the function is decreasing. Or the y values are decreasing, same thing. And then after that point 1, -3 down here, after x equals 1, right, again looking at this from left to right, going left to right, it's going down, 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 hits this point here, and then up, 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 right? The function values, the y coordinates are increasing. So from this x equals 1, from 1 and then all the way to the right forever, the function is increasing. So I'm hoping that you can see this is very easy to determine when you're given a picture, in my opinion. Now what we would state, right, what we would state is that 1, this function is I'll say where it's increasing first. Right. So I would say the function is increasing on the interval, right? And when they talk about the interval, we're talking about an interval on the x-axis. So the function's increasing on the interval from 1 to infinity, right? Because from x equals 1 onward to the right, going left to right, the value of the function, the y value, is going up, right? The graph is going up. And again, make these open intervals, just put parentheses on the ends, right? Great. And part number 2 here, I guess, where is the function decreasing? Right, the function is decreasing on the interval, and after this I'll just say on, and just know that I'm talking about an interval on the x-axis. When we saw in the beginning, if from negative infinity up to 1 on the x-axis, the graph is going down, the y values are decreasing. So from negative infinity up to 1, and again make these open intervals or parentheses on the ends. And that is all. All right, this is all we're asked to do for these exercises. State where the function given is increasing and where it is decreasing. It's very, very simple, in my opinion. Okay, so let's do that again for number 2. Got exercise 19, right, the very next one in the text. So the very next one is a little more curvy. And you see, if I look at it from left to right, it's going up. It's the function's increasing, hits a high point here, right? So going up, hits a high point here. We'll talk about more about these points, these high points and low points, in another video, right after this. And then it's decreasing, decreasing, decreasing up until this bottom point here, this dip, this valley. And then we're increasing again forever, right? Notice the arrow there, right? Arrows on the ends. So once again, I'll draw a very rough sketch of this and just highlighting the important numbers on the x-axis that matter, and then we'll state where the function's increasing or decreasing. Right. So again, here just a very rough sketch. All I did was really highlight important numbers, just integers on the x-axis. Now that point that was at the top of this hill looked like it was at about -2.5. It wasn't actually above -2 or -3. It looked like it was in between them. And they did ask us to estimate, so I'll say -2.5 or -5 halves is the x-coordinate of that point at the top of this hill. And then at the bottom of this dip here, this valley, this low point over here was underneath x equals 1. It looked very much like underneath x equals 1. Right. And those are all I really need. I need the -2.5 and the +1 are the numbers that are going to be mentioned here when I state where this function is increasing or decreasing. So again, looking at it from left to right, as I mentioned way back here, I always look from left to right when talking about where is a function increasing or decreasing or constant. Starting from here, looking at this from left to right, clearly the function is increasing, but up until this point at the top of this hill. Right? So that's from -infinity on the x-axis, to the left forever, because there's this arrow here, right, going this way forever, all the way up to -2.5, right? So on this interval, from -infinity up to -2.5, the function is increasing. Clearly, right? The y values are going up. Then, from this point at the top of this hill, keep going left to right, the y coordinates are going down, right, where our function is decreasing up until the point at the bottom of this dip or this valley here underneath x equals 1. So it looks like from -2.5 on the x-axis up until x equals 1, the function is decreasing. And then from that point underneath x equals 1, this bottom of this valley here, this dip point, left to right, the y values are clearly going up. The function values are increasing for the rest of the way. From x equals 1, and there's an arrow here going up forever, from 1 to infinity on the x-axis, the function is increasing again. Alright, so here's what we're going to state. So first I'll do increasing, right? So this function, this function is increasing on, now there are two intervals with a gap between them, a space between them, where the function's increasing. Now you may recall, when writing interval notation, if you have multiple intervals with a gap between them, you're going to represent that gap with that union symbol, right? The word or symbolized in set notation. So again, going left to right here, the first interval we notice the function is increasing on is from -infinity up to -2.5. Again, make these open. And then to represent the gap, right, because there's a gap where it's not increasing anymore, it's decreasing, so then I got a union here for the gap. And then from 1 onward, right, from x equals 1 to infinity, the function is increasing again. And once again, make these open intervals as parentheses everywhere. All right, so they would say the function is increasing on, the interval from -infinity to -2.5, or from 1 to infinity, the union of those two. All right, and then where is it decreasing? Right, the function is decreasing on the following interval. Now there's only one interval I pointed out here where the function is decreasing, and that's the interval on the x-axis from -2.5 to 1. So from -2.5 to 1, and again just make these open intervals, right? Parentheses on the ends. And that's it. This is what they're asking us for, right? What I just put in the box over here. Where is this function increasing and decreasing? Just state the intervals on the x-axis over which that happens. And again, in my opinion, very, very simple stuff. Okay. And that's pretty much all I'm doing the whole video. Alright, so next one is, I'm just going to go in order here. Just number 3, exercise 20 from the text. So back here, scrolling down, here's exercise 20, this curve here. And once again, I'm just going to, it looks like this low point here, where it goes from decreasing to increasing at the bottom of this valley, it looks like that's underneath -1.5. Again, they're asking us to estimate here. And then it goes increasing and then reaches a top point here, which looks like it's at x equals 2. I'll just eyeball it. It might be a little less than 2, but looks like x equals 2 is good enough. And then decreasing again. Right, again, always looking from left to right. Alright, so once again, I'll just draw a quick sketch of this and state where it's increasing and decreasing. Easy enough. Alright, once again, here is a very rough sketch of the graph they just gave to us. And this time, instead of writing out all the stuff below it, alright, let's just point it out here, going from left to right on this graph, from the left forever up until -1.5 on the x-axis, graph is clearly decreasing. The outputs are decreasing, the function values are decreasing, going down. And then from this valley point here up to this top of a hill, the function values are clearly going up. We're clearly increasing. So that's from -1.5 on the x-axis up until 2 on the x-axis, and then from 2 to infinity, right, to the far right forever, the value of the function is going down, decreasing. Okay, so over here, once again, the function is increasing on only the one interval from -1.5 to 2, right? The value of the function is going up as I increase x, or as I move from left to right. So from -1.5 to 2, and then again, just make these open intervals. And then where is it decreasing? Now, just like in the previous example, there are two intervals over which this function is decreasing with a gap between them, so I'll be using the union symbol again. Right, so the function is decreasing on the following intervals. The first one, always left to right, start on the left, right? From -infinity to -1.5 on the x-axis, right? Over that interval, the graph is going down, the function is decreasing. So from -infinity up to -1.5, and again, just make them open. Union for the gap, right? Union, right? Because then there's this interval where it's increasing, and then we have another interval where it's decreasing from 2 on the x-axis to infinity. Over this interval on the x-axis, the value of the function is decreasing. Okay, again, very, very simple. All right. Next example, exercise 21 in the same text. And looking at this graph here, now this one, see there's this dotted line at x equals 3. That means that it's now not really there. So x equals 3 looks like what they call a vertical asymptote. The graph approaches that dotted line but doesn't actually touch it. Right. Okay, well, going from left to right though, see how the graph is going up, so increasing up until this, I'll say this point here at x equals 1. Might be a little to the right of 1, but I'll just say at x equals 1. And then we have the function decreasing, decreasing, decreasing forever until we hit x equals 3, right? I know there's no graph on x equals 3, but the graph, the function is decreasing to be, until you get as close to 3 as you wish. So I'll just say until 3. All right, then jumping over to this piece of the graph, we're going up, right? Going left to right, the graph is going up, the function's increasing up until x equals 4 here. There looks to be a peak at top of a hill. And then after x equals 4, the graph is going down again, decreasing. All right, so once again, I'll draw a rough sketch of this, ignoring the y values. All right, because again, when you're asked about where is a function increasing, where is a function decreasing, the only values that matter are the x values, right? What are the the intervals on the x-axis over which the function values are increasing or decreasing. So once again, a very, very rough sketch of the graph that they gave us. And again, I'll put little arrows on this. Again, always looking left to right. As I go from left to right, the graph is going up here, so the function is increasing up, and from negative infinity up to x equals 1. And then from 1 to 3, clearly the graph is going downward as I go from left to right. So the function is decreasing. Then from 3 to 4, going left to right, the graph is going upward. Right? So the value of the function is increasing. And then from 4 onward, 4 to infinity on the x-axis, the value of the function, the y values are going down. So the function is decreasing. All right, so there are 2 intervals of increase, 2 intervals of decrease with gaps between them. So I'll be using the union symbol for both of these. So I'll just write, increasing. The function is increasing on the following intervals. We see here, right? From negative infinity, far left up until 1. Right? So from negative infinity up to 1. And again, make these open. And then in union with, because then it's decreasing, and there's a gap between intervals where it's increasing. And then it's increasing again on this interval from 3 to 4. Again, just make it open, parentheses, there you go. So the function's increasing on these intervals. And the function is decreasing on the following intervals. Right now, again, increasing here, decreasing from 1 to 3, right? From x equals 1 to x equals 3. But again, open interval, right? Put parentheses around those. Gap, right? Union, and then decreasing again from 4 on the x-axis out to infinity, right? From 4 to the right forever, the graph is going down. So from 4 to infinity. Again, parentheses, make that an open interval. And there we go. That is all we are asked to do. Great. All right, then I have just one more page, two more exercises from the text. All right. And I'll do the same exact stuff. All right, so exercise 22 from the text. So there's 22. Oh, okay, so we're looking at this picture. So, figure 22 is for number 22 is for figure 16 here. Right. Then exercise 23 mentions local maximum and local minimum. We'll talk about those in a future video. Right. For right now, I just want to estimate the intervals where the function is increasing or decreasing. So again, we got these arrows on the ends. Just remember what those mean. They mean go up forever over here, down forever over here. But looking at this from left to right, though, function's increasing up until this point, which is above negative 3 on the x-axis. And then we have the function decreasing, the y value is going down, till this point, which is above, underneath positive 3 on the x-axis. And then for the rest of the way, the function's going up. The value of the function is increasing. All right, so once again, I'll make a little rough sketch of this and answer their question here. Right. So once again, very, very rough sketch. And just highlighted the important points. All right, the top of a hill here, the bottom of this valley or this dip. And looking at this from left to right, clearly the y values are going up. On this piece of the graph, the function's increasing. And that's from negative infinity on the x-axis to negative 3. And then from that point down to this point, right now, from negative 3 on the x to positive 3 on the x, the value of the function is decreasing. Right? The y values are going down. And then from this point underneath x equals 3, the function is going up. The value of the function is increasing. Right. So the function is increasing on the following intervals. We have from negative infinity up to -3 on the x-axis. The value of the function is going up. And then we have a gap, right, we have in union with, and then from 3 to infinity, the graph is going up, the graph function's increasing again, +3 to infinity. And the function is decreasing between -3 and 3. Right? From -3 to 3 on the x-axis, clearly the y values are going down as I increase x. So on the interval from -3 to +3, but again, make it open, parentheses on the ends. And that's it. Very, very simple. Alright, and I've got just one more of these, right? They've all been pretty similar. Just gotta pay attention to your graph, right? Over what intervals on the x-axis are certain things happening. And my last example is going to be exercise 24 from the text. Alright, so here, see, it's a little different. Alright, a little different. You see how on the ends of this graph, there aren't arrows. There are just points. The graph stops. So this graph stops at this point, which looks like it has an x-coordinate of 7. And over on the left side here, it doesn't go down forever. There's no arrow here. There's just a point. And that looks like it has an x-coordinate of, I'll say, -7. Right. So if I'm going left to right, the graph starts at -7 on the x-axis and stops at +7. It doesn't go to infinity or negative infinity on the x-axis. So I hope that's clear why I'm putting this example in here. Right. And again, we're asked in 24 to estimate the intervals where the function is increasing or decreasing. Right. All right, so once again, I'm going to make a very, very rough sketch of this and state those intervals. So once again, final example, I have another very rough sketch of the graph that they were given, and I put up only the important numbers on the x-axis, right? Like that far left endpoint looked like it had an x-coordinate of -7. This point here at the top of this hill looked like it was above -3 on that graph. Then at the bottom of this valley looked like it had an x-coordinate of +3. And then at the very right end of the graph, that final point, that ending point, looked like it was at 7 on the x-axis. And looking at this from left to right, as the inputs increase, what's happening to the outputs? Well, they're increasing on this piece of the graph, decreasing on this piece of the graph, and increasing on this piece of the graph. But again, not forever. Right? This isn't going down forever on the end. This isn't going up forever on the right end. Right? They're stopping at certain points. So the function's increasing. Well, it looks like there are 2 intervals of increase with a gap between, so I'll be using that union symbol again. The function is increasing on, and again, this first piece of the graph isn't from -infinity to -3, right? The graph's not going to the left forever. It's only from -7 to -3. And that's it, right? No negative infinity. And again, just make it open, parentheses. Right? And then you have a gap, right, where it's decreasing, and then you have from 3 to not infinity, not from 3 to infinity, but just from 3 to 7. Just from 3 to 7, the function values are going up. The function is increasing. Make it open. Now, I have seen other texts where they make these closed, put brackets. This particular text keeps them open, right? And you should probably just have them open. Great. And the function is decreasing on just one interval. And that's between -3 and 3. Right? From -3 to 3 on the x-axis, the function is decreasing. The y values are going down. So from -3 to 3, and again, just make it open, parentheses on the ends. Easy enough. And that is all. So yeah, so pretty simple in my opinion. Again, I've said that a bunch of times. Just look at the graph you're given. Look at it from left to right. Right? As the x values, as the inputs increase, what's happening to the y values? Where are they going up? Where are they going down? And then you just state what intervals on the x-axis over which that's happening. Right. Great. And I'm hoping that watching me go through these 6 examples here help you in some way when you're asked to state where a function is increasing, decreasing, or constant. I mean, I know nothing was constant in any of these, nothing was flat anywhere, but that could happen when you're asked to do that stuff, with a graph on your own. And thank you very much for watching.